It is observed that when a higher temperature object is in contact with a lower temperature object, it will transfer heat to the lower temperature object. Both the objects will approach the same temperature, and in the absence of loss to the other objects, they will then maintain a constant temperature. We call this temperature as final temperature. They are then said to be in thermal equilibrium. In this experiment, we need an electronic balance, lighter gun, a Bunsen burner, a tripod stand with wire gauze on top, beaker tongs, beaker 250 ml, and mercury thermometers. Put beaker A on electronic balance to get the mass of beaker A. Record the mass of beaker A as M1. Add 100 ml of water into beaker A. Record the mass of beaker A with 100 ml of water as M2. Get ready to boil beaker A. Boil beaker A. And now, while waiting for hot water, we prepare beaker B. Add 100 ml of tap water into beaker B. Measure the water temperature in beaker B. Record the reading as T1. And now, water in beaker A is boiled. Turn off the fire to stop boiling. Measure the temperature of hot water. Record the reading as T2. Put the tap water from beaker B into beaker A. Stir the mixture of water for 10 seconds. Then only take the temperature reading of the mixture. This is the final temperature. Now the last step. Move beaker A onto electronic balance to get the mass of beaker A with the mixture of water. Record the mass of SM3. From this experiment, we managed to get the final temperature Celsius degree, which is the experiment value. When the hot and the tap water are mixed together, they will eventually come to an equilibrium. The resulting final temperature will be somewhere in between the two initial temperatures. This is apparent as the colder tap water will heat up while the hot water will cool down. The temperature of the tap water will increase, thereby decreasing the temperature of hot water. So, evidently, the amount of heat lost by the hot water will be given to the colder tap water. By experiment, the final temperature measured is degrees Celsius. Now, let's calculate the final temperature by theoretical, that is, by using thermal equilibrium equation. mH, mass of hot water, and mC, mass of cool water, can be calculated from the measured values. This difference between the value of final temperature measured in the experiment and the theoretical value calculated through thermal equilibrium equation. The percentage error is 0.17. The law of conservation of energy. Follow the law of conservation of energy. The heat released by hot water, heat loss, will be absorbed by colder tap water, heat gain. It may seem that heat loss equals heat gain, but this is not completely correct. Why? Because this will only happen if experiment is conducted in a closed system. The percentage error occurred because of energy transformation. Refer to conservation of energy.